What is a network and why should you care? If you want to work in cybersecurity, you need to understand networks, period. It doesn't matter if you want to be a penetration tester, a SOC analyst, or security architect. Every single attack, every phishing email, every piece of malware, data breach happens on a network. Networks are the foundation on which everything sits. So let's start at the beginning. What is a network? A network is a collection of two or more devices connected so they can share information. That's it. Is your phone talking to your Wi-Fi router? That's a network. A company's 500 computers are all connected to shared servers. Also, a network, just bigger. Your smart thermostat, your doorbell camera, your voice assistant, all of these are on your home network. In 2026, the average household has over 20 connected devices. That's 20 things on your network that all need to communicate with each other. Think of it like a road system. Individual houses are the devices. Roads are the connections. Ethernet cables, Wi-Fi signals, fiber optic lines. People traveling on those roads are your data, moving from one place to another. Some roads are small, neighborhood streets. Others are 8-lane highways. But the basic idea is always the same. Connect point A to point B so something can move between them. Here's what changed in recent years. Networks used to be mostly physical cables in a building connecting computers to servers. Now a large portion of business networking takes place in the cloud. Companies run workloads on AWS, Azure, and Google Cloud, which means their network extends far beyond any physical office. Virtual networks, software-defined networking, and zero-trust architectures are more complex now, but the fundamentals we're covering today haven't changed. You still need to understand the basics before the advanced stuff makes sense. Let's look at types of networks. Local Area Network, or LAN. This is a network in a small, contained area. Your home network is a LAN. Devices are close together, usually connected by Ethernet cables or Wi-Fi. When a SOC analyst says they are monitoring the internal network, they're usually talking about the LAN. Next, Wide Area Network, or WAN. These connect networks that are far apart. If a company has offices in New York and Chicago, the connection between these two office LANs is a WAN. The internet itself is the biggest WAN there is. When security professionals talk about perimeter defense, they're talking about where your LAN meets the WAN, where your internal network connects to the outside world. Next, we have Wireless Local Area Network. Same idea as a LAN, but wireless. When you connect to Wi-Fi at a coffee shop, you're on their WLAN. Next up, we have Wireless Local Area Network. Same idea as a LAN, but wireless. When you connect to a Wi-Fi at a coffee shop, you're on their Wireless Local Area Network. From a security perspective, wireless networks introduced additional attack vectors, such as evil twin attacks, air sniffing, and rogue access points. We'll cover those in a future video. And lastly, we have cloud and virtual networks. This is the one worth adding in 2026. When a company runs infrastructure on AWS, Azure, or Cloud or Google Cloud, they are creating a virtual network. VPCs, subnets, and security groups. They follow the same fundamental rules as physical networks, but These are defined in software. If you are going into cybersecurity, you will encounter cloud networking. Understanding how it maps back to these physical concepts is essential. Of course, there are other types, MAN, PAN, and SAN, but these are the ones you'll deal with most when starting. How does data actually move in a network? When you send a message or load a website, your data doesn't travel as one big chunk. It gets broken into smaller pieces called packets. Each packet contains the data you send in, plus extra information about where it came from, where it's going, and the order it should be reassembled in. Imagine you are mailing a book to a friend, but the postal service only accepts envelopes. So you tear the book into sections, put each section in its own envelope, number them, and write your friend's address on each one. They arrive, maybe out of order, maybe through different post offices, and your friend puts the sections back together using the numbers. That's packet switching. That's how the internet works. Every packet includes a header containing metadata, the source IP address, the destination IP address, the protocol, and a sequence number. When security tools like Wireshark capture network traffic, they grabbing these packets and letting you inspect them. You can see exactly what's being sent, where it's going, and how. That's why understanding packets is foundational. It's what you actually analyzing when you do packet analysis in a SOC. One more important concept. Not all traffic uses the same rules. TCP is like certified mail. There's a handshake, delivery confirmation, and retransmission if something gets lost. UDP is like dropping a postcard in the mailbox. Faster, but no guarantee it arrives. Different applications use different protocols, depending on whether or speed matters more. Web browsing uses TCP. Video streaming and gaming often use UDP. Why does this matter for cybersecurity? Every attack happens on a network. Malware needs a network to spread. Phishing emails travel over a network. Data exfiltration, this is when an attacker steals data, requires the network to send it somewhere. Ransomware communicates with command and control servers over the network. If you do not understand how networks work, you won't understand how attacks work. And if you don't understand how attacks work, you can't defend against them. When a security analyst looks at network traffic, they need to know what normal traffic looks like before they can spot something abnormal. Is that device supposed to be sending data to an IP address in another country at 3 a.m.? Is that workstation generating unusually high DNS queries? Is there traffic on a port that your environment doesn't normally use? These are the kinds of questions analysts ask every day, and the answers all start with understanding how networks function. AI-powered security tools are making this easier. SIEMs use machine learning to baseline normal behavior and flag anomalies, and AI SOC agents now triage alerts autonomously. But the analyst still needs to understand what those tools are telling them. AI flags the anomaly. You determine whether it's a threat. That judgment requires networking knowledge. In fact, if you want to use tools like Wireshark, Nmap, Splunk, or any SIEM effectively, you need these fundamentals. Every certification in cybersecurity, Security Plus, CYSA, CISSP, tests networking knowledge because it's impossible to separate security from the infrastructure it protects. Let's jump into some key terms to get comfortable with. Protocol. This is a set of rules that devices follow to communicate. Like a conversation which has unspoken rules, you talk, I listen, then I respond. Devices need agreed upon rules for sending and receiving data. HTTP, TCP, DNS, and DHCP, all protocols. We'll break these down individually in future videos. Bandwidth. How much data can move through a connection at once? Think of it as the width of a pipe. A wider pipe means more data can flow simultaneously. Your home internet plan advertises bandwidth, 100 megabytes per second or 1 gigabyte per second. Latency. How long it takes for data to get from one point to another. Low latency means fast. High latency means slow. Gamers know this one well. It's what you feel as lag. For security, high latency can indicate network congestion, a man-in-the-middle attack, or traffic being routed through unexpected paths. IP address. Every device on a network gets one. It's how devices find each other, like a mailing address for your computer. There are public IPs. These are visible on the internet, and private IPs, visible only within your local network. We dig in deeper into this in the next video. Next term is port. If an IP address is like a building street address, a port is like an apartment number. Different services use different ports. Web traffic uses port 80, HTTP, and 443 on HTTPS. SSH uses port 22. Understanding ports is critical for firewall rules and for recognizing when traffic is using unexpected ports, a common indicator of malicious activity. A firewall. This is a security device or software that monitors and controls network traffic based on rules. It's the bouncer at the door, deciding what traffic is allowed in and out. Understanding them starts with understanding the traffic they filter in. Networks are the playing field. Attackers and defenders both operate on them. Before you can understand firewalls, intrusion detection, or packet analysis, you need to know what a network is and how data moves through it. This was the foundation. Build on it. Next video, we zooming in on IP addresses, how they work, why they matter, and what the difference is between a public and private IP.